Yes, sir.
Okay, shall we start again?
Yes, sir.
Okay. Good afternoon, everybody, and I welcome all for the next session of our webinar on Internet of Things. Internet of Things is one of the fastest growing technological space which is going to affect each one of our both society and industrial aspects. So realizing the importance of IoT, we have started a couple of sessions on IoT. In one of our first session, we talked about IoT and its meaning and how it is going to affect us. And in one of the second sessions, we talked about web architecture for Internet of Things. As you know, any global phenomenon like Internet needs an architecture. So in the second session, we talked about web architecture. And in this session, we covered that how existing Internet can be extended to include these things, and these things can be made part of the Internet. So once that is done, then in the next session, we thought you about how secure this Internet of Things is all about. Because whenever you want to ask business or humanity to do operations on any internet platform, then the first question they would ask is like, see, will my data be secure on that, or will I retain my privacy? And that was answered in the session number 2 that you see on the screen. So now that I have internet, I have understood it, and I have a web architecture for that, and I have answered your questions like privacy and secrecy and security. Now it's obvious question that if I am interested, how is that I can use the IoT? And this comes under what is known as applications of IoT. So application of IoT is a session which will tell you how to use IoT structure or infrastructure for developing devices and tools which can be used in our context. So let me start with some background basics of IoT. So let me describe what is IoT. And as you see in the screen, the main concept of IoT is the ability to connect loosely defined smart objects and enable them to interact with. So let me clarify certain things. So the objective of IoT is to connect things which are loosely defined. By that, what we mean actually is you can connect the thing without much restriction. That means it could be a sensor, it could be a radio device, or it could be a TV and all. So we don't insist too many restrictions on this connection interface. And these are defined, smart objects. So this is not like when we are connecting something to IoT, it is not a stone or a piece of a brick, or it is a piece of a wood and all. It's a smart object. So by smart object, we mean that it is capable of doing certain things like sensing the environment, collecting information from the environment, if possible storing it, and if possible processing it, and if possible transmitting it. So these abilities makes an object smart. And once this is done, these are capable interacting with other objects. So if there is a smart object, it is capable of interacting with another smart object. And it also capable of interacting with the environment. For example, if you have put a camera, which is IoT enabled, then actually it can take photographs. Similarly, if you have put a sensor in a garden, it is capable of actually interacting with the environment and collecting information regarding temperature and humidity. And in addition to that, these smart devices are capable of actually interacting with complex and legacy computing devices. What it means is, if there is a big server, then a couple of IoT things can send information to that, can take command from that, and so on. Similarly, if you have installed IoTs in millions of numbers, then actually big data servers can actually collect this information from the IoT device and process. So IoT is a phenomenon which things are connected, capable of collecting information, transmitting information, interacting with each other, and the legacy system. So now that I have this phenomenon of connecting things and processing data, this gives me an additional ability to do certain things, and that is called enabler. So that means IoT enables me to do certain things which were not possible earlier. What does it do? It will allow me to install sensors in my buildings, vehicles, and common environments, and this can also be carried by people and attached to animals, and will communicate among themselves locally and remotely in order to provide integrated services. What it means is, sensor becomes the building blocks of IoT device, IoT environment, in which a sensor installed in a garden can communicate with the gardener. And a sensor or a device installed on a patient can communicate with a doctor or a medical system. And it can do this kind of communication either locally, that means it can do within a garden or outside the garden, or it can do within a hospital, or it can do outside the hospital. So, and remotely also, that means it can send it to a network where actually a doctor is staying in another location which is 1,000 kilometers away from that, and that it also can do it. So when this capability is understood or realized, then people will start using these sensors or these IoTs for multiple purposes. Smart subject will densely populate human life and human environment. That means, I told you, a patient can be installed with an IoT device, a pet dog can be installed with an IoT device, or an animal, if you want to study in a wild environment, can be installed. So that means it will become part of the human life. On the human environment, for example, you can install an IoT in a traffic jam, in a traffic interjection, or you can install an IoT in a security mechanism, and so on and so forth. And these devices, they actually interact by providing, processing, and delivering any sort of information or command. What it actually means is, these installed devices can provide information that they collect, process the information they gather, and deliver that information to another one. For example, information regarding the health condition of a patient can be conveyed by that IoT to a doctor. That's what delivery is about. And this information could be of anything, any sort. For example, it could be a picture if it's a camera that you have installed, if it could be humidity if a sensor is installed, and it could be another device like a temperature of a vehicle where actually that can be done. And they're also capable of taking a command from you. For example, if you have an IoT enabled camera or IoT enabled sensor, you can send a command to that. For example, take this particular photograph, or tell me what is the temperature in the garden now. So these kind of commands, like a programming commands, can be conveyed to these IoTs, and they will actually obey that. And the objects in the environment will be able to tell us about themselves. For example, a camera will say that whether it has enough power to continue for another few hours, or a sensor installed in a road or a garden will tell you what is its condition, whether it's on or off. Okay. And then state means on or off. And it is surroundings. That means, for example, if there is a IoT installed in a traffic junction, it can tell you that how many vehicles are passing through that one. Or if it is installed in a car, then it will say how many cars are ahead of it and behind it. That kind of a thing. So when IoT is installed, it will make you enable where actually devices can communicate with each other. So what does it mean? So what does it actually mean is, it has some value proposition. So in industry, whenever a new technology comes, the first question they ask is, how does it benefit me? So one of the fundamentals way in which any new technology can benefit you actually is called value proposition. And IoT can help you to gain productivity and cost savings. So productivity is which will allow you to do more work or get more results for the existing efforts, or it will make you to save certain cost or some material, so that will result in kind of a saving. So for example, it can save you a capital investment in building a company, or and it can labor or other one. So one great example that which will illustrate is, see, Verizon is a company which is a kind of a cloud computing company, which has saved more than 55 million kilowatt of annually across 24 data centers. Data centers are the locations where these cloud computing companies build their IT infrastructure by deploying hundreds of sensors. I told you sensor is a basic IoT, and control points. Control points are those where actually you tell whether a particular machine is using enough power or not, whether there is additional power which is consumed. Control point throughout the data center connected wirelessly. That means for all the 24 data centers, it connected and by installing. And the result actually is a reduction of 66 million pounds of greenhouse gases per year. And you know, one of the accusation against any industrialization is that it actually releases carbon, which in turn will create pollution, which will in turn actually create the reduction in the ozone layer. Now here is a clear example of IoT being installed in a company called Verizon and saving a lot of energy. The advantage is that these sensors are capable of taking their own decision and reducing either the power supply and down. So in turn actually causing a lot of benefit for the industry. So that value proposition I told you, now I can tell you an example. See, one thing that you should remember about IoT is this. IoT is like a language, or it is like electricity. So it will find an application wherever it is possible. For example, a person can use language to tell something to his friends, or some person can use the same language to write a story, and so on and so forth. Similarly, electricity can be used in home or in field or in factory or in ground or in sea or in space. Similarly, IoT is a very generic resource which is actually waiting to be deployed. Deployed anywhere, different places. So let me tell you certain examples. So IoT in action, for example, at individual level, it will make our lives easier. For example, you can turn on your heater before you get home, or it can help you to drive efficiency. Efficiency is spending less resources to gain more results. So for example, you can turn on your washing machine when electricity usage and prices are fall in the middle of the night. We all know that most of our students download content from the internet after 12 in the night, because that time it's either free or it will cost you less. Similarly, it is possible that you will turn on your washing machine at a time when actually electricity charges are less. Or also it will help you to anticipate things without going to a specialist. For example, if you are under a medical care, an IoT installed on your body can tell you the parameters like your status of sugar or blood pressure or heartbeat. Similarly, an IoT installed on your vehicle can use the status of its components like vehicle status or this condition of tire or condition of engine and so on and so forth. So this is essentially what IoT will do for you. There are many other examples. For example, mobile devices which are connected to IoT enabled environment can adopt silent mode when entering a meeting room if this is a request of the meeting moderator. And you know, if you have conducted any event and all, first thing that happens at the beginning of the inauguration is the moderator will ask you to switch off your mobiles. But now, if in an IoT enabled environment, this can be done automatically. Okay. And suppose you are entering an area like a sensitive area, an area like hospital and all, alert user to turn off the radio before. For example, you don't want to play music in ICU unit or in and around an ICU unit. Similarly, you detect when enters a car, and for example, if you are carrying a mobile IoT device, then if, as soon as you enter your car, what would happen is actually it will actually move from your mobile, I mean the records that is stored on your mobile to the recording system or a music system available in the car. Similarly, now that I told you some general application, it is also possible in something like emergency services could remotely and automatically alert it. For example, if you have a huge building, then if you have installed an IoT at every location, and if there is a fire in a certain corner, that can be detected because that sensor is capable of detecting a temperature variations, and that is one kind. Secondly, suppose you have installed an IoT enabled device on a patient, then actually it can detect the medical parameters and drop beyond a critical threshold. For example, if BP is very down below a certain expected level, then that can be conveyed into the the doctor. So now that I told you certain examples, what it should convey you is that, so you just think of a situation, there is a chance that IoT can be employed there. Okay. So what does this mean? So this has a consequence. The consequence is actually you will get a world of interconnected, uniquely identifiable. That means each IoT has a separate address. When virtual representation, they can be managed from a distance because they are programmatically accessible, and that is positioned over a network. That means, as I told you in the web architecture, these IoT devices are actually placed above our existing internet. Okay, and this will create a new economic wave. That means the way web created companies like Google and other things, now we have a chance of actually creating a new kind of economic development, or in fact economic revolution, because these connected devices, when put in total numbers, turn into millions of things, and because there are millions of things, they can be created lot of many services on that, and this will create a service economy as well as for the market for the devices. So the basic paradigm of IoT is where everything is connected and will be redefined, and the way humans and machines will interface. For example, now I don't have to come back to home to switch off my TV, or I don't have to come early to home to switch off my, switch on my heater. So the interface between machines and will be redefined because the IoT is enabled this. Okay, and with around them. That means the way we treat our patients, the way we treat our gardens, the way we treat our animals can change the way because IoT is enabled. Okay, so the essential ideas of so far I told you is IoT has application which ranges from home application to industrial application to a medical application to a an educational application. So at this point, are there any questions? Sridhar?
No questions, no, sir.
Sridhar, any questions?
No, sir.
Shall I proceed?
Yes, sir.
Yes, sir. So now that I have told you the possible things, yes, sir? Yes?
Proceed, sir.
Okay.
I think there is some delay.
Okay. The session number 3. Okay, the objective of this session I will tell you now. So this I told you only a background kind of a thing. Okay. So agenda of this session is Internet of Things is a very useful concept, and it is so useful that it will find application in every human endeavor. It finds use in industry, society, institution, and individual lives. So what are the objectives of IoT? The major objective of IoT are the creation of smart environments and self-aware things. So in order to create an environment which is enabled by a smart device, so there are two possibilities. One is a smart environment in which installed basis of IoT devices will help you to control your environment remotely. And secondly, you can build some tools and technologies which are self-aware things, which are capable of understanding their environment and act accordingly in an autonomous mode. Okay. So what do you mean by a smart environment? For example, you can build a smart transport system where actually machines or IoTs will take care of certain managing like traffic jam or the pollution control and so on and so forth. There could be a smart products. For example, there can be a medical product which is capable of telling whether it is already expired or not, or whether it has been put in the air conditioner as required by or not. Okay. And there could be a smart city where actually you manage the basic utilities and other things in a more efficient manner. So smart environments would cover all this. It could be building, it could be rural areas, energy, health and living, etc. And what are these self-aware things? Self-aware things are for actually climate. For example, if you want to understand the variation in the climate, an IoT device which is capable of self-awareness, that means it will find out whether there is a higher temperature or lower temperature. And similarly, a self-aware things will decide whether a food is stale or fresh, or whether the vegetable has come from the farm right now or it was stale. And energy, that means efficiencies. Mobility, whether a particular item is at a particular location or not. And digital society and health applications. So that means the fundamental objective of IoT is to create a smart environment and a smart self-aware thing. Smart environments are those where actually built-in IoT devices will take certain decisions. A smart, self-aware things where actually these things are capable of conveying information which is built in with those objects. Okay. And why are you doing all this? So for example, let me take an example of a smart city. So why do I use IoT here? The key focus is to make cities smarter by optimizing resources. For example, today a major city like Mumbai and all have always the scarcity of water and electricity, right? So now if you can install IoT, and as you see from my first webinar in this, actually the installation of selective places by IoT will tell you how to avoid theft by people who are not authorized to use electricity. Similarly, it will allow you also to prevent leakages. By doing this, actually you optimize your resources. And secondly, it will also help you to feeding its inhabitants by urban farming. Today, actually, all major cities depend on the surrounding rural areas for their vegetables and other animal products. Now, it is possible that by using remotely controlled tools, actually you can build an urban farming. And one of the greatest curse of any major city today is actually traffic jams and congestion. This can also be reduced to certain extent to IoT, because IoT device installed across the paths in the roads in the city can convey certain information regarding the congestion and clarity of roads to the passengers, so that actually they can take diversions. Okay. And by doing this, actually we will help people to travel fast. Okay. And increasing accessibility to essential services. For example, where do I get medicine? Where do I get hospital? How do I ensure that my ambulance reaches the hospital at the fastest route? This can be done. And at a higher level, this also can help you to introduce security systems. For example, today there are many threats, like the open railway systems will have somebody will put a detonator there, or somebody will create a problem in a restaurant and all. So now IoT devices, if they are installed, like they say upar wala dekh raha hai, so that kind of a cameras will help you to overcome that. And biometric things can help you to ensure that only authorized people will enter locations like banks or ATMs and so on, so forth. And even things like national identification. Say, for example, one of the major problems that many of the Indian towns face is actually there is an accusation that foreigners, like neighboring country people, have come and staying there, and we are not in a position to identify them. So now with the schemes like national identification, Aadhaar card and all, it is possible. And if you make them IoT enabled, then if there's a genuine card or whether it's a duplicate card, can be detected using these same technologies. Okay. So this is what the whole point is. The whole point is actually how to use how to use IoT in building a smart city and meet its objectives. Okay. And secondly, we are having a movement called new green movement. That means we should reduce using the natural resources to the least extent, and also we have to protect our environment. And this movement is called green movement. Okay. Now, smart devices like IoT have come here to help us in this regard. See, smart is the new green, and green products and services will be replaced by smart products and services. So wherever there is a need to use a natural product or like a wood and all, a smart device will take care of that. So whenever a smart device is there, then you are saving your natural environment. Smart products will have a real business case. For example, energy and efficiency up to 30% can be gained if you are using an IoT-enabled environment. Okay. This trend will create what is known as smart environment and spaces. That means you use less of the natural resources, you gain more for your inputs, and you actually make more decisions regarding both yourself and your environment by using the IoT devices. So any question at this point of time, Sridhar?
Yes, sir. Is speed of connectivity a limitation?
Yes. Actually, speed of is connectivity limitation. But again, see, not all applications need very high speed connectivity. Say, for example, if you are trying to collect information about the temperature or humidity in a garden to be conveyed to the farmer or the landowner who is about 100 kilometers away, then speed doesn't matter. But suppose you have an application where actually the changing parameter of a patient to be conveyed to a doctor immediately, then speed matters. Well, then there are speed lines which will be allowed, operated for that kind of a special cases like hotlines and all. Yes, speed is a matter of concern, but again, not all applications need high speed. For the application that need, we will have special provisions for it. Yes.
How strong the controller has to be in IoT application, particularly on communication aspects?
Yes, actually, see, again, it depends on the kind of the application that you are having. For example, if you have a sensor, okay, and then you are conveying the information like the humidity or this one, the controller and the communication controller need not to be that rigid. For example, that information is available anyway, publicly accessible kind of a thing, and there is no sensitivity, privacy or security attached to it. Okay, so in that case, controller could be of ordinary grade. But suppose you are collecting some information about a patient, which is a health concern issue, and which involves like privacy and also the security aspect, or if you are collecting some information regarding the PIN card and ATM card, then in that case actually communication protocol should be very strong, and depending on the nature and the seriousness of the data which is being collected, like a health or financial information, adequate kind of a cryptographic methods will be applied to ensure that the data is kept secret and it travels across the across the network very securely and safely.
Can you explain the consequences again?
I'll go back. So what I mean by consequence is this. See, suppose a phenomenon starts happening, then if it gains numbers, then that will create a new world which is called a consequence. For example, more and more people are using mobile devices. So that means more and more people are also using internet. So what is the consequence? Since more and more people are connected to net, now it is possible for them to create businesses which will allow them people to buy online. So why online is a consequence? Because there is an underlying trend in people are buying more computers and more devices, more mobiles. So it is a consequence. So consequence is a new reality created by the preceding reality. Another example, now more and more people use, buy vehicles. So what is the consequence? We'll have a traffic jams, and we also more carbon emission, which will create a kind of a environmental pollution. Similarly, see, more and more people use mobile devices. So more and more students will come with mobile devices. What it means is now mobile learning can be practiced, because now that's the consequence which is made possible by the previous developments. So in the case of IoT, what it means is now that IoT devices are being installed everywhere and they are connected using a web architecture, which in turn actually gets connected to the internet. What it means is now it is possible that my device can convey my information to me and to another person, and if another person is aggregate such information, then that becomes an industry altogether. So by consequence, what I mean is there is a phenomenon of getting IoT installed everywhere, and there is an ability to connect them to internet, and this connection enables me to connect to any device anywhere, and all devices to talk to each other. This resulting will create a new world order where there is an economic proposition, because an entrepreneur can develop a particular IoT devices to take advantage of this one, or a new industry may come, or new processor may be developed to enable this IoT device, or somebody come up with a new programming device or a programming paradigm which will help us to program these devices which have less power, less memory and all. So this is what I mean by consequence. And this will definitely have an economic implication. Since there is an economic implication, all of us like engineers and MBA students must be taken, because we eventually enter in one part or the other in the industry sometime, right?
I want to develop an intelligent water leakage system which can detect leakage.
So did I answer your question? Water leak.
I want to develop an intelligent water leakage system.
I want to develop?
I want to develop an intelligent water leakage system which can detect.
Now, I told you, see today now IoT to. Okay, yeah, this is possible. See, for example, okay, water leakage is a phenomenon. That means now if there is a pipe which is intact, then there won't be any leakage. In that case, humidity around that pipe will be always zero or negative. I mean, it's only humidity which the environment has. But suppose there is a leakage, then the humidity around that pipe or surrounding that pipe will increase. Now you can always build a sensor which is capable of detecting this difference in terms of humidity measures. So now if you ask any climate expert and all, they say like temperature or measuring humidity or all those things are very straightforward things, like the way you measure a temperature of a patient or the or a temperature of a location or the light and all. Okay. Now it is possible to develop that application, and now there are tools and kits available in the market. For example, Raspberry Pi is one tool which is available, or Kinesis is one tool which is available, or the many tools are available. It's very straightforward.
There are more questions, sir. We'll take them after some time, sir.
No problem. No problem. Okay. Okay. So now, now that I have told you a general applications of this one, now let me take a holistic view of IoT. That means what are the categories in which actually I can develop an IoT application? See, I told you IoT is a worldwide phenomenon, and everybody in the population of the entire 8 billion population in the 5 people can actually take advantage of this. Like it's an internet, an elderly person can also use internet, a student can also use the internet, an industry can also internet. So in order to, if you take a holistic view, then you have to look at this entire phenomenon and try to figure out what are the different categories which are available in IoT. See, IoT application space is very diverse, and applications serve different users. Okay, that means very diverse. See, diverse means actually diversity. We normally say, India is a very diverse country. We have some 34 official, state languages. We have a couple of religions, and so similarly in IoT, the applications are very diverse. Different users categories have different driving needs. Why somebody use IoT depends on the need that he has. For example, government will use it for something, an individual will use it for something else, a doctor will use something else. Okay. Based on this, we can actually classify the categories into three. There are individual citizens like a student or an elderly person or a businessman, okay, as an individual who want to use this IoT device. For example, in one of my earlier presentation, I told you that there is an IoT device which will help a kid or a child to how to brush correctly. Okay, that's that kind of a thing. So this is the first category. And the second category of target audience which might use IoT is a community. It could be a group of people, or it could be a group of students in a college or in a city or region. And the third one is the enterprise. So broadly speaking, either an individual is interested, or a community is interested, or a business is interested. Okay. So why does an individual would be interested in this? Probably it will increase the safety of themselves and the personally or the family members. For example, a remotely controlled alarm system or active detection for elderly people. For example, say if there is a fire in his home, an IoT device installed there can tell him that there is a small fire problem in his home when he is actually in office. Or for example, if you are an elderly people in the home and if they fall, and an activity detection, for example, they have got up from their bed and moving and they have fallen, and this can be actually detected. So this is at a personal level. So they also might use it, for example, to execute certain activities in a more efficient manner. For example, see, buying items from the shop is a big problem because you have to make a buy list, a list to be bought, item to be bought and all. Suppose you have an IoT device and you have installed it in your inventory system, like, and then you can also use that personal inventory reminder. This is at a convenience level. And also, for example, monitoring health and parameters. For example, your sugar can be monitored using this IoT device. So in this slide, we are talking about the IoT application at an individual level. A business can also be interested in IoT. For example, they will be interested in through three angles. Increased productivity. That means, can I install IoT so that with existing 5 employees, I can get more productivity? That's the first question. Or can I install IoT with in such a way that actually I can reduce the number of security staff that I have in my organization? Instead of recruiting 5 security people, I will install certain IoT cameras so that I can reduce them to 2. So that's the kind of thing. Market differentiation. Can I build in certain features to my product which actually come due to IoT so that I will get a market gain? For example, if I have a camera, an ordinary camera, and if I can install a kind of an IoT enablement in, will it make my product superior so that competition can be overcome? Cost efficiency, for example, instead of appointing one security guard or one clerk, I can use an IoT enabled devices so that actually instead of paying thousands of rupees, I can get this advantage in just few hundreds. So the second target audience for IoT is an enterprise who will be looking for these 3 angles. And the third one, which is a major one, is the society. Society at a different level. For example, it could be a corporation in a Delhi city or a Mumbai city, or it could be a national government which is at Delhi, or it could be a state government. So this is called society. Society as a user in the concern with the issues of importance for the whole community, whole population. It's not an individual or a business. So some of the things that should be there to ensure public safety. Can I install IoT devices so that I can monitor who is moving in the roads or who is moving in the college campus, so that security can be established by collecting those information and passing it to police or others. They protect the environment. For example, if you have a hilly section or a very wild environment in and around your town, so that means anybody who is unauthorizedly going there, cutting a tree, all those things can be protected by using this. And to create a new jobs and ensure existing are sustainable. So is it possible that, say for example, when mobile device came, there were many jobs created. Similarly, for example, when computer came, desktop jobs were created, desktop publishing for creating documents or publishing or project reports and all. Similarly, his IoT will help society to create more jobs and sustain existing. So this is the third category. So now that I have identified 3 different categories, I will be identifying the 3 different levels. For example, it can be at individual level, at a bigger level. But now these levels are different. For example, IoT can be used at city level. Say for example, at city level, it can be used for integration of technology for quicker data analysis and we need to coordinate an effective civil response. For example, if there is a fire in a particular hotel in a particular corner of the city, IoT device installed that can convey that information to a fire extinguisher, and that in turn will convey it to a traffic control so that the fire engine can smoothly take a ride and reach the destination. This kind of a coordination it can do. And it can be used at a building level. For example, if you have an apartment, security is a big problem. If hundreds of families are staying, then having a security system, identification system, biometric system is a big challenge. And now actually it can help you. For example, if you are running a hospital or a factory, then IoT enabled devices can help you to take attendance of the people using a biometric, or customer behavior if you are having a retail mart and other things. At a different level, for example, there can be an application of IoT even at a smart vehicle level. There will be increase in the development of smart vehicles that have low or possibly zero emissions. Say, for example, today emission is a big problem and controlling that is a big challenge, right? So now it is possible that by installing IoT devices at the exhaust of your vehicle, we can keep monitoring what is the level of emission it is doing, and by controlling that kind of a combination of say petrol or fuel, you can try reduce it to zero. There will also be connected infrastructure. For example, a vehicle can be connected to the manufacturer or a service provider who can tell you the current state of health which is happening in your car. For example, the air pressure in each of your tires or the health of your engine and so on. Okay. And also materials will be adopt more use of smart materials. Smart materials those which do not cause environmental pollution. So this is at a different level. A third level, for example, fleet management. Say, for example, if you are managing a big city and if there are some peak traffic hours and all, in that case actually, and there are rogue drivers or there are accidents and all, in that case actually this can be used. An IoT enabled vehicle or a traffic system can help you track vehicle location. You can say like this particular vehicle is at this location. Hard stops, if somebody stops all of a sudden by applying a fast brake and rapid acceleration, anybody violating a traffic rule, they can also be controlled. So this will tell you that IoT can be applied at different levels. It could start at a city level, it could come to a building level, it can go to a vehicle level, or it can go to a management level. So here is an interaction time. Any questions? What I covered so far is actually what are the different audiences for IoT applications. They are individuals, enterprises, and society. What are the different levels it can be applied? It can be applied at building level, city level, national level, or vehicle level, or even at a device level. So any question at this point of time on this topic?
How human to machine interaction is achieved using IoT?
How machine interaction?
Human to machine interaction.
Okay, see what actually happens is, see now forget IoT for some time. Now actually you think of a computer or a mobile. Okay, so there is something called a big science called interface science. That means how to build interfaces which are convenient to an user. It's called actually, that science is called ergonomics. Okay, so now that is what done. And in most of the internet application, it is machine to machine, and these machines have a people behind it. Okay, IoT is just an extension. So in place of a computer, you have a device called IoT. Now there are two interfaces. One interface will connect that machine to another machine, IoT. At another level, it will actually help the user to operate it. For example, if you have a sensor, then you can use, you can have an interface so that you can decide the parameters that sensor has to measure, or the parameters level that you can do. So that can be do either through a kind of a keyboard interface or a remotely controlled mobile operation, or it could be a programmatically done. We are doing on your computer and it is getting changed in that one. So there are three interfaces, either a physically hardware available like a keyboard, or it could be through your remote health device like TV remote or your mobile device, or through a server where actually programmatically you can access.
Is IoT equals sensor plus computer?
Little more than that. For example, sensors and computers, for example, we had this already, this combination. When we have this wireless network, wireless sensor network, WSL, they actually a combination of computer and sensors. But they were limited in their scope. That means they would be operating in a locality or in an area. Okay. Whereas this IoT, they go beyond that. That means they are not confined either in existence or in communication to a particular building or a particular city or particular location. Whereas these wireless networks, by definition, you know, they are limited either by city or by building or by campus. So it is wireless, when IoT plus computers plus network makes IoT a better tool.
Sometimes it may be issue of no connection or signal, maybe down. What can we do at that time?
Sometimes what, sir?
Connection or signal may be down. What is the solution at that time?
No, this is true. See, any network phenomenon is subject to some variation. For example, even if you are using a mobile and if you are traveling in air in a flight or in a train, there are areas where actually you don't find network activity. Similarly, there are days in which you don't find internet connectivity. So this is not something strange to any network phenomenon. For example, even if you are using vehicles, buses, city buses, and there are days in which service is not available. So when you say network is not connected or connectivity is not there, so this is a very temporary phenomenon which could be, set right by the network providers as soon as possible. But IoT devices are quite capable of actually overcoming those kind of a limitation. For example, if IoT device is there and if net is down for a certain period of time, then it is capable of storing that data and forwarding it when actually the network is up. But the fact remains that no matter how sophisticated your network, whether it's internet or mobile network, there are occasions where it goes down, but these devices are capable to large extents to overcome that challenge.
Is there any constraint on spectrum used for IoT?
Any constraint on?
Spectrum used for IoT.
Constraint on what, sir?
Spectrum.
Yeah, it's a kind of like a bandwidth and all. For example, if you are using RFID tools and all, there are frequencies which are restricted, which are permitted, which are allowed to be used. Okay, it's like, see, wireless network used by a police and police force in a particular city. There are frequencies which are reserved for them. So similarly, the spectrum is used, but that depends on the occasion, that depends on the service provider, and so on and so forth. It's something like, say, radio, like certain FM radio and all, they are limited permitted frequencies. Similarly, all these devices have a manufacturer defined and government regulated frequencies, which will be known only when you start applying them.
Are GSM applications IoT applications?
Yeah, GSM is part of this actually. GSM gives you some kind of a geographical system, right? So now you can always put a sensor which says what is the latitude and altitude of that particular location. Or you can put an IoT device on a moving vehicle which keeps on sending you information about GSM, its geographical location. So for example, suppose a ship is traveling across the sea, then you can always an IoT application which is capable of measuring these GSM parameters and getting conveyed to either to a satellite directly or to a home base or something like that.
What is the role of government in implementing IoT for a public utility?
Okay, see, I told you IoT, like other internet mobile devices and other networks, is actually it's a publicly manageable and public affecting phenomenon. So once this starts happening, then government's role is to regulate certain things. For example, if you are using a cell, then there is a TRAI, actually, Telecom Regulatory Authority of India, which will decide what kind of messages can be sent on that. How do you, avoid marketing messages to be sent from your cell, and so on and so forth. Similarly, if it's the internet, and what needs to be protected, what kind of websites should be shown, or if it's a newspaper, then what kind of information news can be published. So there will be a regulatory authority for every network phenomenon or any industry. Okay. Similarly, IoT is also an industry level thing. For that, government already has come out with regulation both at national, international, and world level. So these largely deal with kind of the tools, the IoT devices, and whether they are health hazard or not, how protected they are, how do they affect the environment, or what will happen once you discard them. That's the e-waste and all. So these kind of a regulation policies already in place, and it's also getting evolved. So like any other phenomenon, government has a key role to play in this. First thing, it will enable people to use them. It will also enable manufacturer to see and ensure that they develop these tools in according to the specification, though that there are side effects are less. Okay, and they also ensure that the operators, like the businesses and organizations, they use according to the norms and requirement of things which will not put public into any kind of a harassment or a problem.
We will continue at the end, sir. Questions.
Okay, no problem. Okay, so now that I will take to a broader look at this, the potential application of the IoT are numerous. I told you how a person can use language. There is no limit. Somebody can use the language to write a song. Somebody can tell a story. Somebody can write a novel. Somebody can produce a film, and so on. So similarly, they are diverse and permeating into practically all levels of everyday life. For example, it could be at individual, enterprise, or society level, or it could be at building level, room level, or city level. So it is practically okay. And enterprises and society as a whole. Now let me list certain specific applications so that it shows you the diversity. And I will go a little fast in this because there's I want to indicate the possibility and also an occasion happening, not more than anything else. Okay. See, for example, one of the reasons why where IoT can be used is actually better energy efficiency. For example, things like smart thermostat could adjust our energy usage based on the local factors in environment. For instance, if your thermostat knows the temperature is going down in the next 3 hours because it is connected to another website which tells you the weather forecast, it might bring down the AC output. For example, it knows that at 2 o'clock in the afternoon that it's going to rain in the afternoon, and if you don't need AC by then, it can adjust the levels of temperature. Similarly, if your water sprinkler knows that it is going to rain today, it might avoid sprinkling water because that would be waste of this. So the first level you can use it for the energy efficiencies. Now look at this point, your IoT is installed at your location, but that is connected to weather forecasting website, which in turn can collect information and get that. And this is machine-to-machine communication. There is no human individual involved in that. And it can be used for a better disaster management. A group of intelligent robots, and all these robots are kind of an IoTs, actually can clear a website disaster sites very fast because they coordinate among and across themselves. Imagine a range of autonomic entities like land robots, drones and sensors and satellites all collaboratively working to save people as soon as earthquake or a hurricane is about to land. So this is a second example. We are always interested to know the nature, and some people actually want to know better about the wild nature. For example, what are the animals in a given forest? What do they do? What are in terms of numbers? What do they, how do they spend their entire day? So you can always install and tag those animals with an IoT enabled device, and actually would have even better understanding of the natural ecosystem they work. How do animals react to it? What is their food habits? So you cannot physically go there and stay in a forest to understand this, but an IoT enabled device can help you to do this. And aerospace and aviation industry, for example, IoT can help security and safety of the an aeroplane. For example, see a typical aeroplane like Boeing will have millions of parts, and it is big task to check whether all the spare parts are genuine or not. Okay, so now almost all this problem in the aircraft industry faces the problem of suspected unapproved parts. It may be a screw or it could be a component which can come, which is not approved, it's not manufactured by an approved manufacturer. Okay, so now it is not possible to detect them because naked eyes will not help you to do that. But now it is possible that using RFID attached to these parts, that means a manufacturer will attach an RFID device to this component, which can be verified at the level because a machine will be reading it, verifying an RFID and verifying its authenticity. Automotive industry can also use, for example, it can be equipped with advanced sensors and actuators with increased processing powers. So that means they can sense the level of fuel efficiency. They can sense the temperature outside and actually reduce the air condition. And applications include smart things. For example, they can measure pressure in the tire. For example, if it reaches a certain level, then there is a chance of your tire going puncture. It is not efficient to run a vehicle with reduced pressure in your tires. That can be conveyed to the driver. Proximity of the other vehicles. For example, if you are in a traffic jam, it will tell you like whether you can move forward or not because it tells you the vehicles which are in the vicinity. So this is another example. Telecommunication industry, it can help you to cover couple of technologies into one. For example, IoT will create a possibility of merging diverse telecommunication devices and create new services. An illustrative example is the use of GSM. Somebody asked me about GSM and near field communication, low power Bluetooth and other things into together with a SIM card technology. That means your device will have one identity card or identification number like MAC number, which can help you because IoT is monitoring that. Medical and health applications, there is no limit. For example, a cell phone with RFID sensor capabilities can perform for monitoring and medical parameters. For example, a cell phone which is connected to an IoT device which is installed on a patient can help a doctor to measure the parameters or vital parameters from a distance. Independent living. See, now there is kind of a condition because of the improvements in the medical and healthcare. More and more people are living longer. So they normally live minimum 20 or 30 years after their retirement. But now that they don't have an active role, that means they don't have an active profession, so social problem or a societal problem. And they want to be, for example, now that education is becoming a big thing, normally what happens is parents educate children well, and that education will take them far away places like Bangalore or United States or Harvard. So elderly people will be staying at home. So this IoT device will help them a lot. For example, look at this. Monitoring social interaction using wearable and ambient sensors. These devices which are on the known by the parents or the elderly people are connected to the children or the doctors or caretakers. They can actually use them. Pharmaceutical industry, for example, pharmaceutical, one of the problem is selling an item which is already expired or keeping an item outside which actually needs a cool storage. So this kind of a thing can be avoided, because if you have a IoT implement or a device attached to that one, it will tell you what is the duration in which it was there in the cool, or when was actually it is expired. I'm particularly going with a little speed on these slides for a simple reason that my job is only to illustrate examples on a broad scale. It can be used in retail, logistics and supply chain management. What it means is, see, companies like Walmart, they have extensively used this. See, what they normally do is actually they will control every item in a chain. For example, they buy at one side and from the wholesale people, and they transport to their shops and they sell them. What they've done is, whenever they actually have an item which is either an RFID enabled or IoT enabled, and when somebody sells an item, immediately that information goes back to the control room saying that one item in this particular shop is actually sold. That means stock levels have come down. Okay. Similarly, if they locate all such item sales in a particular town, it will help them to send items to replenish that. That means all the sold items should be replaced. This will help. For example, you look at the last round. Whenever a customer goes to a shop and doesn't find an item which he wants, that would mean a loss to a business as well as frustration to the customer who has come to the shop. This can be avoided because using an IoT, because as soon as an item is sold, that information is conveyed to the seller, to seller and also the service provider, who will replace it with a new item. Manufacturing industry can also great, because it can control and manage the entire process from production to its processing to operation and so on, so forth. Process industry like the petroleum industry or drug industry can also do one. See, for example, infrastructure and integrated wireless monitoring petroleum personnel in critical onshore and offshore operations. See, this is actually cities and all. So in those cases, actually, you do not have enough resources or enough technology or enough things to support them. So in that case, IoT-enabled society, infrastructure will help them to get connected to the head offices and process them. See, for example, you look at the last one, IoT can help in reducing the number of accidents in the oil and gas industry by equipping the containers of hazardous chemicals with intelligent wireless sensor nodes. That means if something should be shut down, for example, if hazardous element is being carried in a ship, and if it meets an accident, then IoT can actually tow that ship into a safe harbor without asking the people in that, because any attempt of people to go there actually will put their life in the risk. Environmental monitoring, I tell you the levels of pollution, the levels of other ingredients in the environment, the levels of manure in a garden, the levels of fertilizers which is put into a garden, all this can be managed when using an IoT-enabled devices. Transportation industry, like we have this toll system and all, they can be helping you to fare collection, screening of passengers for either security reasons or for the items which is being parceled or illegally brought. That kind of a thing can be done. Okay, and also helping you for the more efficient and can self-scan and weigh themselves. For example, certain trucks or lorries, when they are passing through the toll and all, they are tolled according to the weight, and you find the weigh bridges across the highways and all. But these weigh bridges actually ask you to go there and you have to actually physically weigh that. But if there are IoT devices are there, then actually the weight of a vehicle or carrying a luggage and all can be conveyed to the toll manager or the toll people in the toll booth directly, and they can get clearance before they pass on. Agriculture is also a big field where actually you can, for example, during outbreaks of contagious disease, for example, there are diseases which actually affect the livestock like mutton, chickens and all. Now suppose all these animals are attached to some kind of IoT and tagged, then you can always say like these are the likelihood of animals or chickens which need to be separated so that there is a likelihood of a kind of a contagious disease being spread. Okay, and also vaccination and media and entertainment. This is an important, for example, deployment of IoT technology will enable ad hoc news gathering. For example, if all of a sudden an event happens, all of a sudden some accident happens. Now suppose you can, if you have installed devices, IoT and all, like a camera or a microphone and all, then you immediately convey that information either from this state of accident, place of accident or a state of disaster. This is a very important. See, one of the issues which is always raised in IoT devices like internet is that people would not want their privacy to be disclosed. But insurance companies have come out with a kind of a scheme where actually private information or share some private space with the company in return for a profit. For example, sometimes people are willing to trade privacy for a better service or a monetary benefit. For example, suppose there is a person who owns a car and he wants to insure his car. If the insurance clients are willing to accept electronic recorders in their car, which are able to record acceleration, speed and other parameters and communicate this information to the insurer, they are likely to get cheaper in our rate of premium. For example, if you oblige the insurer that you don't cross a limit of 60 kilometers speed and you will never run when the tire pressure is less than this, and if you allow that person to install certain devices which will tell them, then you are consciously will ensure that you don't cross those limits. And this will help companies to avoid expenses because of some accidents or some kind of a malfunctioning and all. So they don't mind sharing the benefits of those benefits to a user. And now this is an example where actually IoT can help you a lot. Recycling is a process where actually you keep using an item so that actually you don't have to go back to forest or cut one more tree. And this IoT can help you with that also. So far actually I've told you a broad picture of different applications which IoT can devise, starting from agriculture to building management to recycling to manufacturing to refinery. But these are actually the tips of an iceberg. That means the depth and the breadth of the IoT application is still deeper and still broader. At this time, any questions that you want to ask me? Any questions either?
How will safety issue of an individual using IoT-enabled device be handled?
Okay, see, safety is an integral and inseparable part of any IoT installation. And depending on the kind of the device, for example, a sensor is installed in a college or in a factory, okay, or in a floor room or in a garden. So the information that it gives actually that doesn't actually affect the safety of a person. Okay. So in that case actually that is not highly safe kind of a thing and you don't have to bother. But suppose you have installed a kind of a device on a patient and which will be monitoring and critical condition like blood pressure and all. In that case we will ensure that these devices are sophisticated enough that they don't harm the patient. For example, they don't give a radiation which will affect the person because they don't use any sensing devices which will affect the other part of his body. That will be ensured. Similarly, suppose you are using a IoT device in a vehicle and you are using it for your safety reasons, then they have a built-in features which will warn you well in advance. For example, if your vehicle is traveling at a particular speed and if it detects that there is a reduction in the pressure of one of your tires, then it will ensure that that information is given well in advance, and in case you don't obey, it will put in some kind of a process that will bring the speed down of that vehicle or it altogether stops it. So safety mechanisms will be operated in two levels. One, it will tell you to do action, and if in case you don't take action, they automatically take that action.
Who is eligible to work for IoT research?
Okay, see, IoT research eligibility, I will tell you, because my next presentation probably next week or the following week is research direction in IoT. See, eligibility is very simple. Actually, IoT in its development and design is an engineering aspect. Okay, so it actually is the intersection of three things. For example, any IoT is essentially a microcontroller. That means it needs programming. Okay, so and any IoT is also installed in one of the devices like car and all. So it also needs mechanical engineering. Okay, so it's an engineering proposition. So if you are an engineer interested in programming, I mean coding, and if you are good at understanding electronics behind it, and if you are finding an interesting application in no matter whether it's a maritime or a vehicle or and all, that is the sufficient requirement or eligibility for that. But the entire scope of research opportunities probably I will be covering in my next session, probably next week or thereafter. The essential qualification is simple. You must be an engineer because it involves engineering devices like microcontroller, and you should know a little of coding, I mean minimal coding, because you have to control that you need that coding. And finally, you have to know a little of electronics because there are some applications that you do at that level, so that a particular pin on a microcontroller or a particular interface with an external device, that is the minimum thing. But today, every industry is getting like electrified, right? Electronics are built in. So this is a very general specification or a qualification that is needed. Yeah.
Please continue, sir. There are more questions we'll take later, sir.
Okay, sir. So now I'll come to the last stage. Okay. So now that I have built things for people, built for industry, now I take a holistic where actually how the IoT can transform our society at every level, and by adding smart to everything existing. For example, now you have a transportation system which is creating a lot of pollution. Now I can convert a smart transportation where actually I reduce the travel that the person has to do, reduce the pollution that is going to happen. Similarly, I can build a smart hospital and this, so and so on and so forth. So in this particular presentation, I mean the part of the presentation, I will cover the broad sketch or broad possibilities of IoT. Experts have identified and described the main intent of main Internet of Things application that span numerous applications. It could be a smart energy where I get more energy resources, use them very efficiently, and actually distribute them more efficiently. For example, if you remember example of one of the examples that I gave from Mumbai in my first presentation, see, energy leakages is a big problem, water leakage is a big problem. So these smart devices will tell us where is the leakage happening, the quantity and other things. Okay. And smart health, smart buildings, smart transport, and smart industry. Okay, I will go fast. Smart food and water monitoring. So it could help you to water leakage, or it could be have a golf courses, in-field monitoring. Smart health, it will help you. For example, I take certain example, fall detection. So suppose there is an aged person in your home, or if there is a small infant kept at a home under somebody's care, and as soon as it falls for whatever the reason, that can be conveyed to the concerned person because IoT is looking at that. And it could be a speak control, all those things, or dental health. See, earlier I told you in IoT device produced in France, which will help you to help a kid how to brush his tooth correctly by connecting it to a game. It also helps elders to tell which of the tooth they have missed in brushing today. Smart living, these are the examples. Gas monitoring, safety, for example, we all use gases today, and if there is a leakage at a home, a smart device will detect that there is an increase of this gas in the kitchen, and it will convey you that, or maybe it will off the wall, all those things. Smart environmental monitoring, forest fire detection. See, in many of the continents like Australia, Africa and all, forest fire is a big challenge. They are very remote, very broad, very spread across very areas. It is very difficult to detect unless you use a satellite and all. But if you use IoT, to a large extent it can be solved. Smart manufacturing, smart energy, that means production smartly, distribute smartly, consume smartly. Smart building, intelligent building, allowing people, not strangers. Smart transport, for example, whatever the toll payment can be made automatic. Fleet tracking, which vehicle is traveling where, and if you want to control traffic. Smart industry, for example, tank level LTU. See, for example, filling a tanks and emptying the tank is the regular business for this petroleum industry. So now actually physically people measure the tanks, the level, for example, whether the tank is full or not, whether it is emptied clearly or not. Okay. Now you can use IoT devices which will manage this level very easily. Smart cities, already told you. Smart tourism, this is an interesting because smartphone applications supported by QR codes. For example, you can scan this code and get information, and near field communication tanks providing interesting and useful tourist information throughout the city. For example, include information like museums, where are the museums, art galleries, libraries, touristic attraction, because this is a combination of IoT and existing network technologies. And this can also be taken further. For example, the way we build electricity for a rural area and convert into a city, we can also convert an existing city into smart city, smart energy grids, and so on, so forth. So the conclusion is this: IoT is a new tool that has potential to be applied in many ways, in many fields. You think of a field like education or other things, it can help you out. This opens up a new opportunity for innovators and researchers. Innovators, because if you can identify a need and develop an IoT device, it can create fortune for you. Or if you can find out a limitation in the existing theory or technology which IoT is struggling with, then that can open a research for you. So this is open for you. So my next session, probably I told you date is not fixed, could be on research directions in IoT. And this is my contact information. You can always contact me. So this is the end of my presentation. Any question?
How to use IoT to detect coronal mass ejections from the sun?
Okay, there is a thing because it comes under environmental thing. Okay, see, you have to decide the parameters to be measured. Okay, and there are ways to measure that parameters, and an IoT device can be made to learn those measurements. That can be done. But in case you want further details, you shoot an email to the email ID which is there on my screen, and I can send you further details, more specific details to you. Okay.
Is there any application can develop one mobile ad hoc network instead of wireless network?
Mobile, see, wireless network is available because you can create, you have the resources. Mobile network you cannot create because it is owned by a mobile operator, right? So you need all those towers, other things as installation. Whereas in wireless, it is part of an existing internet work. Okay, it's another door in which, another means which you get connected. Whereas to build a mobile ad hoc network, you need mobile operation things like mobile operator and mobile tower and so on and so forth. If you are ready to invest that kind of a thing, then you can certainly do that.
How do we integrate IoT with smart cities project, not as assembly? How do we integrate IoT with smart cities project, not as assembly, installation, commissioning perspective, but as graduate level engineering studies courseware?
Okay, see, for example, see, when you are teaching an IoT, and there is an idea called smart city. What's the basics? In fact, the Indian government under Modi is planning to build 30 smart cities in India. So what's the basic definition of a smart city according to them is actually a smart city where the basic requirement is it is well connected using a wireless network. So that means you can always assume that there is an existing network which is available. Now you are going to build all your services based on this. For example, a hospital can use this wireless network and IoT applications to get connected to a doctor. So now, suppose you are developing an engineering course, then you can select a sector like a medical sector or a pharmaceutical company and assume that this underlying infrastructure is available. Then develop application which will connect, for example, a druggist to a doctor, or a druggist to a pharmacist to a supplier, or a patient to a doctor or a consultant. So these are the application, and these application can be taken as example and included in your course. And in fact, I am introducing one IoT course for my 7th semester engineering students. I can share that syllabus with the person who has asked this question if he shoots an email to this email ID.
What controllers you suggest to implement IoT?
Controller, sir?
Yes, sir.
No, what is that? Controller?
What controllers you suggest to implement IoT?
See, controller is a very generic term. So controller is anything which controls. And in IoT, there are different controls that you have to implement. For example, an IoT device can be controlled on what to measure and what not to measure, what to communicate and what not to communicate, and when to do and when not to do. Okay, and in what format it has to send. For example, it's a generic information temperature, then you can always don't have to control, say that kindly send me information that whatever that you have. But suppose it's a financial information or medical information, then you can say like, see, don't send information in a native format, you encrypt it and send it to me. Okay, so the controller would be a generic term, would mean like what is the level of control that you want to implement. That's always a contextual thing. Okay, so if you ask me at a very top level, controller can decide like what to do and what not to do, how much of that to do and how much of not to do, and when to apply encryption and when not to apply it, when to stop measuring and when to measure, to what extent to measure, and so on and so forth. So controller is a very general concept, but it will be applied based on the context and the kind of the information, whether it's financial, confidential, and so on and so forth.
How can IoT be helpful in equity sector?
Business equity sector? You mean equity means business, right?
I will ask that professor to clarify. Meanwhile, we can take the other question.
Maybe equity or equity, sir.
What are the legal issues opened up by deploying IoT systems in the context of Information Technology Act 2000 of Government of India?
Yeah, see IoT, okay. No, the major questions come from in terms of actually the safety, privacy, and this security. So safety is actually, see for example, you install a device which will it turn out to be hazardous. For example, it is emitting a ray which is not good for health, that kind of a thing. Second is privacy. That means if you have installed cameras across a particular campus and all, are you permitted to take those photographs and what will you do with those photographs? So these are privacy issues. And security issues that say you are collecting some confidential information like health information or say financial information like my ATM card number and all, how do you protect and all? So the IT Act which is there for internet is also largely applicable to this, except that the existence of these IoT devices must be told to every user. For example, see now you in a major buildings and all you see this locality or this building has CCTV installed. So this information should be given to a user in advance because he will avoid doing certain things which are captured by the camera and conveyed to that. So this kind of a warning should be given. Beyond that, there is no additional things except the IT Act of the relevant IT Act.
How good is Raspberry Pi for IoT application?
It's good, sir. So for a beginner, say Raspberry Pi is actually a very good, resource to start your IoT journey because it is both academic in nature and you can start programming at a very, in fact, it supports Python and other languages. So if you're an engineering student and studied programming and you are good at Python, probably Raspberry Pi is the best place to start your IoT journey. You can do our academic projects, even fairly serious and real life application also you can develop, but that's the best point to start with.
Please explain the web architecture concept to achieve connectivity with physical things embedded in electronics.
Okay, I will tell you. See, this web architecture I covered in my second presentation. See, what web architecture says this, see now we are creating a world of IoTs and if you want to connect them, there are two options which are open to you. That means you develop your own communication network which connects this all IoTs. Like see, when mobile devices came, they didn't depend on internet. They created their own telephone lines or mobile networks. That is a very difficult task because IoT is a global phenomenon. You cannot have an other additional network. So what people thought that now actually we will connect these devices through extending an existing internet. But internet is not all capable of getting directly connected to this. And you know, in internet, it actually uses what is known as this OSI layers. So the last layer is actually physical layer where actually computers are sitting. And top level is application layer where application like whatever that will come into like browser and all come. So now if I want to connect this, okay, to IoT devices, I have to do something at this physical layer. So what this web architecture people have thought is actually we'll have three layers. One is physical layer and the network layer and the application layer. In the physical layer, so instead of connecting to computers, I will connecting it to IoT. Okay, and this layer is called perceptual layer because perception means ability to identify a thing. Since all these devices, all these sensors, they sense the environment, it's called perception or perceptual devices. So in a web architecture, we will connect using this perceptual layer to an IoT device. So there are interfaces already established. For example, if you are building a sensor, if you are building a sensor using an electronic, like microcontroller and all, so there are interfaces like that, pin connections and all, which will get connected. It's like see, connecting another printer to an existing internet. How do you do that? You do it at a physical layer, but it will taken care by the application layer, network layer, and so on and so forth. Similarly, your job is to connect at a physical layer using this kind of a physical connection. But the existing web architecture and also another proposed web architecture will have its enough protocols to enable it to communicate with a higher level like network and the applications. It's like connecting a mobile device to a computer network. Instead of mobile, you are connecting a sensor.
Some have asked for reference books to study IoT.
Okay, I think have I included here? Sir, I have not included it, but actually if they send me an email, actually I can share them, sir, because in the previous one actually I had done that one. Okay, but now in this presentation it's not available, but ask them to shoot an email so that I can send them, sir.
Okay, sir. That's all the questions, sir. Thank you very much.
Okay, sir. Thank you very much, sir.
Yes, sir. Thank you.
Thank you very much for you and for the audience asking questions. I guess I met their expectation. Thank you, sir.